So we'll start a new topic, solubility and solubility equilibria. This is actually lecture 1 of this topic. Right. So first of all, we must know what is the meaning for solubility. Solubility. Okay. What is the definition? Solubility is the amount of substance, is the maximum amount of substance. Solubility is the maximum amount of substance that can be dissolved in a solvent. It is the maximum amount of substance that can be dissolved in a solvent to get 1 liter of its saturated solution. At a given temperature T. I repeat, what is solubility? Solubility is the maximum amount of substance. Okay, amount you can express in gram, or you can also express amount in moles. So it is the maximum amount of substance that can be dissolved in a solvent to get 1 liter of its saturated solution. Okay, at a given temperature. Okay, listen. So to get 1 liter of saturated solution, how much substance that we can dissolve? Okay, you know very well, saturated solution is one, right? Is one in which the amount of substance is dissolved in maximum extent. You cannot add a little more, right, in the solution, because if you add a little more, the substance will simply settle down because it's a saturated. That's the meaning of saturated solution. It is the maximum amount, right? The solute is dissolved in it. Okay. So solubility is the maximum amount of substance that can be dissolved in a solvent to get 1 liter of its saturated solution at a given temperature. And remember, it is temperature dependent. You know very well. If you increase the temperature, you can dissolve even little more. Okay, in the saturated solution. Right? If you increase the temperature, saturated solution moves from one to another. Okay. As you increase temperature, in general, you may dissolve even more amount of substance in that. Okay. So while giving solubility for any substance, you should mention at what temperature you are giving that. Okay, solubility depends on temperature. Then we express, okay, this is how we represent solubility. Solubility is usually represented by the symbol S. Okay, and remember, solubility can be expressed in gram per liter or in mole per liter. Mole per liter is also sometimes called as molarity. So we can express solubility in gram per liter or in mole per liter. Okay, if solubility is expressed in mole per liter, suppose if I express solubility in mole per liter, how to convert this into solubility in mole per liter into gram per liter? How to do that? You just multiply this value by its molar mass. By its molar mass of that substance. Okay, molar mass of the substance. Okay, if you multiply by its molar mass, you will get the solubility in gram per liter. Right? So try to keep all these things in mind. Then, based on solubility, we classify salts into different types. Okay, listen. Here I have given the general term as substance, but I am going to focus mainly on salts. Okay, you know very well, salts are neutralization product of acid and base. Okay, now based on solubility, we can classify salts into different types. based on solubility, we can classify the salts into different types. Right? So, classification of salts based on solubility. Okay, listen carefully. We can classify salts into three types based on its solubility in water. Right? I have told you already, we are going to discuss solubility, right, in aqueous solution or in water. So we are going to take water as the solvent. Okay, but the discussion is equally valid for other solvent also. But for this particular discussion, I am going to use only water as solvent. Right now, so based on solubility, we can classify salts into three types. Number one, freely soluble salts. Freely soluble salt, for which solubility value will be greater than 0.1 molarity. If solubility is greater than 0.1 molarity, we call that salt as freely soluble salts. Yes, there are many salts like sodium chloride, potassium chloride, sodium acetate, right, calcium chloride, yes, etc., etc. Many salts are available. These salts are freely soluble in water. Right? Their solubility value will be greater than 0.1 molarity. And we have another type of salt called partially soluble salts, whose solubility value is, if it is in between, right, it is greater than 0.01 molarity but less than 0.1 molarity. If solubility of any salt exists in between this, between 0.1 to 0.01, then we call those salts as partially soluble. Partially soluble salts. Okay, and we have third category where solubility will be less than 0.01 molarity. If any salt having solubility less than 0.01 molarity, then we call those salts as sparingly soluble salts. Sparingly soluble salts. Often, this type of salts are referred as insoluble substances. Okay, we say that the substance is insoluble in water, the salt is insoluble in water. But actually speaking, no salt is insoluble in water. Okay, every salt has some extent of solubility in water. Okay, right. So, we classify salts based on the solubility into three types: freely soluble, partially soluble, and sparingly soluble. Okay, now in this discussion or in this particular lecture series, I am going to focus mainly on sparingly soluble salts. Okay, right. So let me move on to sparingly soluble salts. First, I will give you some examples for sparingly soluble salts. Okay, take them. Examples. Right? Examples for sparingly soluble salts. Okay, this is number one. There are plenty of examples available. Listen, silver salts like silver chloride, silver bromide, silver iodide. Okay, all these three salts are sparingly soluble in water. Remember, silver fluoride, okay, is freely soluble in water. It has solubility, it has little higher solubility, so it comes under freely soluble category. But the remaining three, silver chloride, silver bromide, silver iodide, these three are sparingly soluble salts. Right? Then number two, we have silver chromate, Ag2CrO4. This is sparingly soluble. Like that, many examples are available. Then we have barium sulfate, we have lead sulfate, we have lead chloride, okay, we have barium chromate. Plenty of examples are there. We have barium chromate, right? Then we have examples like copper sulfide, nickel sulfide, etc. etc. There are plenty of examples available for sparingly soluble salts. Okay, I have given few examples here. That's all. Right. Okay. Now listen. So what we are going to do is that in the next lecture, we are going to discuss about how these sparingly soluble salts, okay, dissolve, and in the saturated solution, what is their solubility? Okay, so solubility of sparingly soluble salt. So that is our goal. We will discuss that in the next lecture. Okay, thank you.